In this video, I'm going to discuss just the heat storage system of a climate battery. That means I'm going to focus on the storage medium itself and the insulation or the thermal barrier that holds the heat into that storage medium. Warning, small amounts of math may be included. Let's look at the most common options available for the below ground thermal mass and their most basic characteristic, their heat storage density. Heat storage density simply tells you how much heat a material can pack in before it warms up by 1 degree. These are all measured per cubic foot of material. First up, we have air, which has a very tiny number. This is why when the sun hits our greenhouses, they heat up very quickly, and then they cool off very rapidly when the sun sets. Next up, we have dry clay, loam, sand, and gravel. Each one of these holds a little bit more heat than the other. Now, for reference, here's where concrete sits in that lineup. It's not really a choice for a climate battery, but it is included for comparison's sake. However, most of us are going to water our plants and want to keep the soil moist. That's actually a great thing for our climate battery. We aren't using dry materials. We're going to keep them moist. Of course, our plants don't like swimming, but if they did, here's where pure water sits on the storage scale, which is nice for relative comparisons. With this background, let's move on. One of the most common questions I get is what kind of fill should I use for my climate battery? The most common options people have are clay, loam, sand, or gravel. Let's do some math. For example, I have a 60 by 30 foot greenhouse, and I'm going to excavate 4 foot down. So I have 7,200 cubic foot of storage space. We can multiply that times the material properties on the previous page, and voila. If we look at the difference from most to least, we get 269 kilobtu. But how much is that? A typical 20-pound propane tank for your grill is 433 kilobtu. So 2/3 of a propane tank. Not a lot for what the cost of bringing in fill might be. So the best option is whatever you have available, which is probably what you just excavated. You do want to have nice loamy soil on top if you're planning to grow in it, and watering your plants will help keep the climate battery moist and at maximum storage capacity. Now let's talk about what's happening below the ground. The Earth's surface temperature gradually gets colder as our weather gets cooler in the winter. At depths of 20 to 30 foot down, the Earth's temperature is constant, typically at a temperature near the average annual temperature of your region. Here is a U.S. map of our annual average air temperatures. Where I'm located in South Dakota, that is about 45 degrees. In a high tunnel or a greenhouse without a climate battery and insulation, the daily heat captured will slowly conduct into the ground, and then it will start to dissipate. If we add a climate battery to store that heat, we need to reduce the loss of heat to the surrounding earth, so some insulation is required. Otherwise, it isn't really a battery. So now we're going to add some insulation right below the structure. That changes the heat path so that the heat that we capture and store in a high tunnel or greenhouse goes into the ground right below the structure and is held and stored in place until it gradually fades into the ambient ground temperature that's a little bit warmer deeper down below the ground. I previously did several studies using the software tool called Therm that allows an engineer to model two-dimensional heat losses. All of these scenarios assume that the climate battery soil is at 70 degrees Fahrenheit, which is about the typical level that I achieve going into the cold season. First, I compared 3 scenarios: no insulation, 2 inches of XPS or expanded polystyrene, and 4 inches of XPS. I included the material cost per linear foot at the time when I built it for your reference. Then I added options that took it even farther, utilizing a frost skirt, which further reduces the heat loss through the base of the battery, but it can add substantial costs. I then utilized this information to calculate the return on investment of the various configurations at USDA hardiness zones 3B through 6B. I assumed we would have to replace the heat lost through our foundation with propane, which was costing $1.30 per gallon at the time. So for zone 6B, no more insulation than 2 inches makes sense. We easily get an ROI within 4 years. For zone 5, 4 inches becomes viable. Colder zones, like 3 or colder, will find the frost skirt pays off. Zone 4 is kind of in the middle, and I tend to suggest doing just the single 4-inch layer without the skirt because it does add extra excavation costs and complexity to the installation. Sometimes folks ask if they should dig deeper, maybe down to 8 foot. Maybe they have their own excavator. Building a climate battery deeper will give you more heat storage, but it radically increases all of the costs, such as tubes, manifolds, fans, and electricity to power them. The materials to fully utilize this depth may range up to $20 per square foot for your structure and are only effective if you have enough solar energy to utilize that capacity. I don't recommend the strategy. Instead, save your money to insulate the structure better. A 4-foot depth is often the sweet spot for most applications. But what about a single layer of pipes, 2 foot deep? It does reduce the costs, however, it also greatly reduces the benefits by more than half because there is less heat below the level of tubes to bring up due to its shallow depth. There are lower cost methods of getting the equivalent thermal mass than a single layer of tubes, such as solid mass concrete blocks. An important warning for climate batteries: make sure you know the depth of your local water table. You don't want your tubes being below the water table and constantly fighting with flooded tubes. Next up, I'm going to talk about the heat exchanger pipes. Should you do 4-inch? Should you do 6-inch? How long should they be? What spacing should they be? So many options, so many choices, and so many pitfalls. This video was funded in part by USDA's South Dakota Specialty Crop Block Grant. If you enjoyed this video, make sure to leave a thumbs up and share it with your friends. I'd also love to know your thoughts. Comment down below and let's chat. And if you haven't already, be sure to subscribe for more content like this.